In this video, we'll be talking about the mean value theorem. If f is continuous on the closed interval from a to b, then there exists a number c in that interval such that the definite integral from a to b of f of x dx is equal to f of c times the quantity b minus a. F of c is called the average value or the mean value of f on that closed interval from a to b. And basically, the mean value theorem states that somewhere between the circumscribed rectangle and the inscribed rectangle, there is a rectangle whose area is equal to the area under the curve. Now let's take a look at what that means. The circumscribed rectangle, which is the green dotted line, is the rectangle that encloses the whole entire area from A to B. So it's from the maximum point up here down to the axis, and then A to B. The circumscribed rectangle has an area that's greater than the area under the curve. The inscribed rectangle, which is the red dotted line, has a height which is the minimum value from a to b of our function, and so the inscribed rectangle has an area which is less than the area under the curve. And the mean value theorem states that there's some value c such that f of c, which would be the height of the rectangle, multiplied by the width of the rectangle, is equal to the area under the curve, which is designated by this definite integral from a to b. Now let's do an example. Find the value of c that's guaranteed by the mean value theorem for the function f of x equals 9 divided by x cubed over the closed interval from 1 to 3. So our mean value theorem states that the definite integral from 1 to 3 of 9 over x cubed, and I've written that with the negative exponent so that I can integrate it easily, that definite integral is equal to f of c, which is this factor, times the distance 3 minus 1. So that's the statement of the mean value theorem. Now what we're going to do is integrate this left side and get a value and then solve for c. So we'll integrate. We'll use the power rule, which means we increase our exponent by 1 and then divide by the new exponent. So negative 3 plus 1 is negative 2. So now I have 9x to the negative 2 divided by negative 2, and that's going to be evaluated from 1 to 3. Notice I did the math here. 3 minus 1 is 2. So the fundamental theorem of calculus says that to get a value for this side of the equation, I want to evaluate the expression with 3 substituted in, and then subtract from that the value of the expression with 1 substituted in right here. And then notice I multiplied 9 times 2 to get 18. Alright. 3 raised to the negative 2 is 1/9, and so that simplifies just to a -1/2 because the 9's cancel. And then I have minus a negative, so plus. And then this is just 9/2. Alright, when we do the math here, we have 8/2, which is 4. And that's equal to 18 divided by c cubed. Solving for c cubed, multiply both sides by c cubed, and then divide both sides by 4. We have c cubed equals 18/4. This simplifies to 9/2, so c is equal to the cube root of 9/2. Our next example, find the average value of f of x equals 4 times the quantity x squared plus 1 over x squared on the closed interval from 1 to 3. Then find all values of x in the interval for which the function equals the average value. Now the average value is f of c, so that's what we're going to be finding. Our mean values theorem states that the definite integral from 1 to 3 of our function, notice I distributed the 4, is equal to f of c times 3 minus 1, which is the distance covered by the interval. To make our work easier, I split this into two separate fractions, so 4x squared over x squared is 4, and then 4 over x squared I wrote as 4x to the -2. And then I also did the math here. 3 minus 1 is 2. To integrate then, we'll use the power rule. This becomes 4x, and this is 4x to the -1 divided by -1, which is minus 4x to the -1. Our fundamental theorem of calculus says that we need to evaluate this expression with 3 substituted in, so 4 times 3 minus 4 times 3 to the -1, and then subtract from that the value of this expression with 1 substituted in, so 4 times 1 minus 4 times 1 to the -1. We'll simplify. 4 times 3 is 12. 3 to the -1 is the same as 1/3, so this is 4/3. Subtract 4 minus 4. So 12 minus 4/3 is 32/3. And I'm going to solve for f of c, which is my average value. So dividing both sides by 2 gives me 16/3 for the average value. The other part of the problem was to find values of x in the interval for which the function equals this average value. So all we do then is set the function equal to the average value and solve. So I did a cross multiplication and got 12x squared plus 1 equals 16x squared. Solving now, this is 12x squared, subtract 12x squared from both sides and we get 4x squared, and then 12 times 1 is 12. Divide by 4 on both sides and square root it, and we get x is equal to plus or minus square root of 3. Now they want us to find the values of x that are in the interval. Remember, our interval was from 1 to 3. So the answer for that problem is the x value that's in the interval from 1 to 3 is x equals the square root of 3.